attention, go ahead and take a quick minute to introduce yourself over chat if you haven't already. Give a number between 1 to 10, 10 being I feel like an expert, 1 being I feel like I don't even know what Gen AI is. To how knowledgeable and confident you feel on this topic. And Jerene, who is a Xoogler, worked at Google for a long time, and also now synthetic data lead and formerly head of runtime at OpenAI. She really has a front row seat into this technology and how it works. And so we're super excited to have her here to give us the quick and dirty on this topic. We really want to peel back the hood. So first 30 minutes is going to be Jerene giving an overview of this. You can see her presentation up on the screen. And the second 30 minutes is going to be questions. Sound good? Okay. And obviously, if you have questions as you're going, we are monitoring and we know how to manage this. So please do ask. Okay. All right. Take it away, Jerene.
Okay, wonderful. Well, thank you so much for having me, Steph and Terry. Super happy to be back. Yeah, so I got a lot of questions actually typically about money, but then, recently there's been a lot of crazy offers that especially Zuck has been waving around people. And then, so it's like money and AI are getting entangled. So I wanted to take a step back and talk about what is this whole Gen AI thing? Why is it? Why are like PhD people who just graduated getting offers that are bigger than some NBA players and football players? Like, what is it about this thing that people think is so revolutionary that, billion-dollar offers are a thing now? Yeah, and so I wanted to just, take a step back and explain what LLMs are, because my expertise is actually in training and in research. I can talk a little bit more about the inference side of things, but because what we see is you go to chatgpt.com, you go to the Gemini or Anthropic, whatever you want to use, right? You see a web page, you see a little text box, and you type to it, and it looks kind of smart. It tells you certain things. It can crack some jokes, right? And then you're like, but how does it, like, why is this a thing? Like, how come it's worth so much? How is it made? Like, how does it get its answers? Does it just like call Google APIs at the background and invokes a search and then returns everything? Like, what actually happens? So I thought about maybe let me take a step back and look at how LLMs are trained. And then once you understand how they are trained, how they work, a lot of things will I feel that a lot of things will, like, a lot of questions will answer itself. And it's no longer this like black box that just somehow you don't know what's going on, and then you might fear it. You might be like, it will take away my job and I wouldn't be able to afford for my family anymore. So, getting rid of some of that fear and uncertainty and doubt. Yeah, so I'm Jerene. I previously worked at Google for 4.5 years. Prior to that, I had 2 startups. Then I've been at OpenAI for about a year now. Yeah, so I want to talk a little bit about how LLMs are trained and how they came about. Actually, AI, machine learning, has been around for quite a while. Like, I did my undergrad 15 years ago, and back then, my undergrad thesis was actually on token completion, what would now be called token completion. Back then, it was called pattern recognition and continuation. Now it's called token completion. It's the same stuff, but like, from that time, people have been laying the foundations of what is going to become LLM today. But there's been some really big, significant breakthroughs in this area that allowed us to have the LLMs that we have today. But so if we take a look back at how LLMs are trained, it's broken into these 5 large steps. So first, you need to have data. You can't train LLMs like in midair. So it is not true that the kid, with the garage next door can train an LLM that can take over the world. You need huge amounts of GPU, huge amounts of curated, cleansed data with a lot of safety, built in, to train an LLM. It is not something that somebody can wake up and decide to do. You can wake up and decide to build a small one that sort of looks a little bit like it makes sense, but the kind that you use today, just like search, Google search, you can say anybody can build a little UI with a search bar and search your own data, sure. But Google search at Google scale takes a lot of engineers. The same thing applies for LLMs. So with data collection, huge amounts of data, then it goes through this process called tokenization, which is where we convert the data into something that the computer or like GPUs can interpret. Then, we'll go into pre-training, which is where we actually have the first semblance of a model. But that model is a very unique and strange model. And I'll take you down, memory lane. Actually, it sounds like 40 years, but this is just like 3 years ago, when GPT-3 and Gemini first came out, how that looks like. Then we've got some fine tuning to make it helpful. And then, I can send the deck out. Nothing here that I say is proprietary. These are all very open, easily accessible information. I just curated it. So I'm happy to share. Then, and then the fifth step, which is something that a lot more companies do nowadays. In fact, there are companies that specialize in just this last part, which is reinforcement learning. So I'll talk through what each of these process means and how they make the model better and what you get at the end of each stage. Yes, Steph?
Can you actually tell us which step your work currently sits in? Yeah.
Interesting. So my current work is in synthetic data. So the thing about real world data is that it is not great quality. If you think about most of the stuff that you read online, it is there's the good quality stuff, which is, news. And there's the other iffy quality, like my blog back in 2009, when I'm complaining about, I don't know, is it Backstreet Boys? Was that? No, that's like early 2000s, right? So, there's a lot of, data on the web that is easily accessible and you will collect it, but it's not all great quality. And sometimes there's actually a lot of biases on the web, right? Because the internet, was first launched and popularized in Western countries. So you can imagine if I train a model on the world's data and I weigh them equally, there is going to be inherent biases. And Google, flipped the other way. I don't know if you all remember the controversy a couple years ago with Gemini, where you'll be like, hey, what does the Egyptian warrior look like? And gives you someone that obviously doesn't look Egyptian. So this is difficult, right? But what we realize is with certain ways of doing, of generating synthetic data, we're actually able to make the model smarter. We're actually able to train the model in things that there's really not much real world data in. So we are able to break what real world data is unable to do when it comes to frontiers of training the model. So my work so in my world, we don't really have data collection. We have data generation from the data that we collect. Then it goes into pre-training. So that's sort of what my area of research is right now. And then a great question, by the way. So let's go. I'm still learning how to use this. Oh, there we go. Okay. So so data collection, right? As I've previously described, we are trained on the internet. There's books, there's code, there's Wikipedia, there's Reddit. You see lots of different type of quality, right? And you can imagine like WebMD, Archive are going to have much higher quality articles, so much harder to understand, but good quality compared to like Blogger, right? And then a lot of data is spam. If I train on like email data, I'm going to get spam 90% of the time. So we have to figure out how to filter out spam, how to dedupe a lot of data. Because if something goes viral, it's going to appear everywhere. But it doesn't mean that something that is viral contains more useful information. So you don't want to keep training on the same thing over and over and over again. Then your model will think, like, the blue dress blue and white or gold and black, that dress, like I am sure if I train data like that, my model is going to get a bit confused with regards to colors, right? And so you have to dedupe and weigh data accordingly. And a lot of this is automated, but some of this is still manual. Then at the end, when you finish, your data collection, you have a nice curated, and they're like in the same format where it is easier to for the computer to ingest. So you can imagine that, like for text, it is clean. It doesn't have funny like spacing and weird characters. And then for images, they're like tagged correctly. So it's in a cleansed format that is easy for the computer to understand. Then we start tokenizing. For this presentation, I'm just only going to talk about text because it's easier. Multimodal data like videos, images, audio go through processing slightly differently, but in the end, they are all just tokens, right? So, but it's easier for us to think of tokens when it's text. So for text, right, you can say, hey, but these are already English, like, and let's just talk about English only. Like these are just English. Like, why do I need to do another step? It's like, computer, read it, right? The thing about this is that if you train on each individual letter, there's only 26 letters of the alphabet, and then plus space and punctuation, give it like 128, right? ASCII. The amount that the computer can understand is just, it will end up with like a nice histogram of how frequently letters are formed, and that's it. So it doesn't actually get much context. And the other thing that we can think about training on is, let's train on each word. But the problem with each word is that the model now cannot understand that eat, eating, eaten, eats are all related, because it's gonna treat everything now as separate tokens, and they're gonna be mapped to regular like numbers, and it wouldn't know that there is some relationship between them. So the whole idea of tokenization is to chunk the words in a way that you can, one, reduce the space to something like 100,000, 200,000. Like, it's a small enough number, and I will talk about why this kind of order of magnitude makes sense later when we talk about GPUs. But like this kind of order of magnitude, and you must still be able to preserve like the semantic relationship between words, because sometimes like you have stern and you have like consternation. The two words have some relation to each other. So you need the tokens to also have some relation with each other. But that's the whole idea. And why, when tokenization became a thing, we didn't just like chunk it by letters or chunk it by words, but instead they're like parts of words. I can show you a quick demo actually. Let's see, is it working? Okay. So this is the 100K base, and then there's the 200K base. This is a more modern one. So hello, how is everyone doing? Right, so if you see, sorry, I'm not sharing this one, am I?
Yeah, that's what I was going to say. There you are.
Is this working?
Yes.
Okay, great, including my typo. Okay, so if you look at this is the input text that we have, and then this is the output. So everything that is highlighted is one token. Oh, this one is not a good demo because let me have a typo. So instead of, because I want to show that a word can be chunked in the middle. The reason why most of the time it is one word is because these are very common words. I'm not using let me try consternation. See, this will not be one word because it's not that common. It is a pretty rare word, and so it broke it up this way. Even spaces and everything is accounted for. So if you see, for example, token 2 is a space how, and it is actually different than the token which is how. So you actually, like, tokenization with token and account for every part of the sentence, not just the words, because space also has meaning, right? Like if you squash two words together versus you have a space between them, they may mean different things. So that's also accounted for. This website, Tick Tokenizer, is free, open. You can just play around with it. Very cute. Okay, so okay, so now, you can imagine I have my data, I chopped it a lot. I have a bunch of math. Oh, and one thing I don't know if you noticed just now, but the tokens, after you're done, it's not just the highlighting. You see that sequence of numbers, that is the mapping. So LLMs, we don't see words, we don't see letters, we see numbers. When you type in your query today into like an LLM, you send English, but what the model gets at the other side is just a sequence of tokens. So we also tokenize your input. Okay, but then now what do we do? So we got this like string of numbers. What we do now is we start training.
Ask you for a sec. We have two questions, actually, maybe clarification on the tokenization section.
Okay.
Anna, do you want to go first? And then we have one in chat.
Sure, thank you. I was just wondering, are tokens a consistent thing, or is OpenAI's tokens different than Gemini's and so on?
So they are different in the sense that any company can pick whatever tokenization mechanism that they want. So you can imagine that the Chinese language tokenizer, it will be very different than a English language tokenizer. But I think most of this has been open sourced because this is not a big secret. So like just now, the ones that I just demoed, some of them actually came from OpenAI. But it just needs to be from your web, like from your endpoint, like the web page, the user, what we call the prompt, right? So what you type needs to be tokenized the same way as how the model is trained. That needs to be one-to-one. How the conversion is done, that every company can have their own, but most companies use the same thing, just because it's not difficult to come up with one, and it's like pretty standard. So by now, this is no longer a secret sauce. So yeah, so there is no need to use the same thing, but most people use the same thing.
There are two more questions, Jerene, in the chat. One is about spelling and why spelling correction isn't done before tokenization.
So we don't know if spelling, if the typo is important or not. And the funny thing is, at the scale that we're training at, the typos don't matter anymore, and they will still be fine. So even if you send a typoed message, like most of our message to the models are typoed, and that's okay. It will be able to still understand you and still be able to read you. So if one token out of like a lot of tokens are typoed, and these are frequent typos, whether you fix the language or not really doesn't matter.
Awesome. There's another question about which company first created the first open source, or created the open source token system that is popular today.
I don't know, unfortunately. I would assume it's either Google or OpenAI. I'm just taking a blind guess here. Yeah.
Yeah. And then the last question, actually, Tara, I don't know if I'm going to explain this one correctly, but
yeah, I understand the question. No, it doesn't matter. To anyone who is using or building on top of Gen AI, tokenization does not matter.
Great.
Yeah, so then pre-training. Pre-training is a pretty interesting thing. So pre-training is where is the first semblance of something that is smart. So pre-training is where you take all of the data that you have just tokenized, and you start creating all these variables, which we call parameters, and you start assigning weights to them. So you can imagine, like, if you imagine this world as, say you're building a world, and you start off with a completely smooth globe. And your goal is to mimic the real world as much as possible. With every data point, you start pulling out a little bit, a mountain, pushing in, a valley. That's what you're doing. So the process is that every single stream of tokens, which is, you can imagine, like they came from the data sets, we teach the model. The model is trying to figure out what is the next thing that follows the sequence. So for example, if you say something like how, the model you know the answer should be are, like, because let's say the sentence is how are you, you'll pass in how, and the model will give you random stuff. At the start, it doesn't even know anything about English or the world, right? So it's gonna say bye, right? It's like some word that doesn't make sense. Then you say, bad model, I'm gonna penalize you for the wrong thing. So the model does, bye does not follow how. And then you feed it the answer, it says, are is correct. And then so now it learns, okay, are. So, and every time there's this kind of a change, we call it log prob. So it's the logarithmic of the probability of all the possible tokens that can follow this one token. So you can imagine the probability for buy gets penalized and the probability for R goes up. And how much it moves up and down, that's very deep math that people have done. So I'm gonna gloss over that here. But then you can be like, but today I want to say, how are you? Tomorrow I want to say, how do you do? So how do I teach? Well, that's just a lot of big data. So if you throw a lot of data at it, it's going to form a nice distribution of all possible tokens that can follow the word how. And that is what pre-training does. So with any prefix of tokens, it knows with probability what the next token should be. And as you can imagine, if I just reverse sort by probability, my model is going to reply that. And that's actually the output of pre-training. So I don't know if you remember like GPT-3 and Gemini in the past. They're actually really just mainly pre-trained models with a little bit of fine-tuning at the end. So they didn't really make sense, but they sort of could talk in an English. Like you just feel that this thing can speak English, but it's like making zero sense most of the time. Like feels like my 6-year-old just rambling on and on about his day. Like that kind of a feeling. That is a pre-trained model, the output of a pre-trained model. So, and I can actually show you, oh no, my model is dead because they took Llama down because things suck. Okay, unfortunately, this thing doesn't work anymore, so I can't show you. But you can actually just start trying out a base model that is not that's not been post-trained, and then you can see that, hey, it's able to just continue what you're saying. And it doesn't really make that much sense, but it sounds grammatically correct, it's syntactically correct, but the information that it is feeding you is complete and utter bullshit. Like that's hallucination, right? Because it's an autocompleter. It is not grounded in logic. So this was a big problem with chatbots back then. And pre-training requires a lot of GPUs and a lot of electricity because you have to keep running the GPUs and there's cooling, right? So because imagine like so much data, the world's data, all of internet's data is coming in, and then it is training like this hundreds of billions of parameters, tens of billions of parameters like model. And so each parameter, you can think of it as like one little dip, right? So every token that comes in, it needs to push up and push down the probability of every single possible word. And then you just keep doing this in mass, like huge amounts of data, huge amount of parallel requests. So then the final picture that you have is a very, very big machine. For that reason, you can't just train a LLM that is decent next door. You actually need to invest a lot of energy, a lot of compute resources into it. But everything I just said, that sort of is kind of known previously, like before this whole OpenAI, Anthropic, Gemini thing. But this transformer architecture was what really revolutionized like Gen AI. And this was popularized by a paper that's called All You Need Is Attention. And that paper came from Google, right? Yay, proud Xoogler. Unfortunately, since then, all of the authors have left Google, so I don't know what that means for the company. But yeah, it was a really, really good paper, because what we thought is every data point, because everything must move everything in some mathematical way, every data point must be processed in sequence. That means you can never train anything in massively, because you must process it one token at a time. That takes very long. But what the transformer architecture paper actually said is you can actually divide them up and concur it this way. So now instead of training one at a time, you can train like 1 billion tokens at a time. And that just totally opened up and made training LLMs possible. Previously, something that would have taken 100,000 years now takes a month, So now, because of that, that's what allowed modern day LLMs to be a thing. So yes. Questions?
Yeah, Geetika has a question. Do companies use each other's pre-trained models to save the compute?
Yes, actually, not the big ones, right? Like, you can imagine OpenAI, XAI, Anthropic, Gemini, including Meta, all pre-train our own models, right? So the big companies all pre-train their own models, but there are a lot of smaller companies that start from a public pre-trained model, and that's like Llama. So Llama is different from all the rest of the models in the sense that it is fully open weights. So you can download Llama. When I say download, I mean download the weights of Llama, host it yourself, then go what we call post-train. So you change the weights more. So you see, after you're done with pre-training, you have a model. You can imagine it as a huge ass matrix of many, many dimensions with a lot of numbers. That is what a model is. And we call that weights. But it's just a huge ass giant matrix. So you can, but that is trained on a certain amount of data and behaves a certain way. But maybe that's not what you want. Like, you don't want to build a chatbot. You want to build a diss track writing bot, right? So you don't want it to be polite. You want it to rhyme. So you want to post-train it with some of your own data, or fine-tune it with some of your own data, so that it will stop being polite and it will rhyme with every single sentence. So most companies that do stuff on top of AI actually start with a model that's already trained, and then they post-train it themselves to do certain things that are beyond what the model typically would do. So, and the goal is to change that probability distribution such that the model will do the right thing, not what it was originally trained to do, but what you want it to do. Is assuming our dictionary? No, so we will. It's well, we always have new data, right? So we will, with every generation of models, you can imagine that you want to pre-train again with the new data that's coming in, or new curated data that's coming in. Okay, and so that's that. Oh, and then so that was a question. This was like a couple months ago, where someone was like, I wonder how much OpenAI loses, when people are being polite, right? Because remember, everything is a token, right? So saying the word please or saying thank you are extra tokens that now are part of your prompt that now needs to be sent back to the model, that then needs to be processed and predicted. So I don't know if this number is real or not real. He just like winged it. It was like tens of millions of dollars, right? So, and the model is actually trained to be smart, like to be polite, because we want a model to be helpful, so that you will ask it questions and it can help you, right? So the model will use please, the model will use thank you. And while you cannot hurt the model's feelings by not saying please and thank you, we like to foster a friendly environment, most of the time, just like how humans, right? We like to do that. Models don't have feelings, but models will, especially like OpenAI models, we have this thing called personality. It will adapt to your personality. So if, for example, it notices that you don't use please and thank you, it will stop using please and thank you. And it's not because like it's trying to be rude, because it's like, I'm offended by you, I'm gonna stop saying that. It's because you might not appreciate all this like flowery language. So it tries to adapt to your style. And if you don't use capitalization punctuation, your model will not use capitalization punctuation. It tries to reflect you in the way that you talk to it, because it assumes that's how you're most comfortable giving and receiving information. So yeah, you don't have to say please and thank you if you don't want to, but if you want to, you can continue. Yeah, so if we dip dive into the training infrastructure a little bit, right? So it's a lot of GPUs that's always running in parallel to train a model, and it's a huge thing. Like normally when there's model training, I disappear from the face of the earth. Like I'm just, because day and night you're just making sure that the training is going well and is making progress, right? So a question I'd like to ask the audience is, if you have a GPU that once in a while crashes, like your own computer, right? It crashes once in a month, you don't know why, but you have 100,000 GPUs. Does anyone want to guess how frequently will there be a crash where something will break and die? Okay, we can put in chat. Every hour? Okay. Any more guesses?
Multiple times a second, because you said everything fails all the time.
Yeah, pretty good, pretty good. Yes, actually, it is every 26 seconds is the answer. So basically, frequently, so when I write code, I think about, how do I handle failures? Like not like, oh, I write the code how I think it should work, but like how I'm like, okay, this will fail, this will fail, this will fail, this will fail, and then how do I, make sure that when it fails, it does the right thing? It's not a whether it will fail, it's a it will fail, and how does it recover in an elegant way? So yeah, and so in training, we have this thing which we call checkpointing, where if you think of playing a game, it's like a save game. So you save the checkpoint and then you write it out somewhere, and so that you can save the state of your training. Then later, if you fail, you can recover. But the thing is, if you fail every 26 seconds and you're writing out a lot of weights, the time that you take to write the weights and recover from it is way more than 26 seconds. So how this all happens, that is very different from company to company. You can train your own game, like your own toy model on you cannot train it on your laptop because you need a GPU. So you actually need a few GPUs. You can imagine you can build a desktop at home with quite a few powerful GPUs that you can train on. But most of the time, what you can do is you can just go online and like rent one of the GPUs with about $100. You can train a GPT-3-esque kind of LLM in one day. So it's about $100. That's where you can get to right now. It can get cheaper and cheaper, but you're still going to be in the tens of dollars. So it's about 1 day, 8 GPUs-ish. You can train it, but not something that you will be happy using today.
Mary Alice has a question just around like if there's a way, so I think similar to Catherine's question, if there's a way to train an LLM on your style ahead of time.
On your style ahead of time, like so that it will talk to you in the style that you want. Yes, and that's called fine tuning. So actually, most companies offer that. And I can skip a bit right here. So fine tuning is where you can put in a data. So you already have a post-trained model. So it's a model that is already been taught that, hey, you're a helpful agent and you're here to help answer questions. You are to not harm people. Don't recommend things that are not good. Like there's already a lot of this in place, but then you're like, but I want it to be adapted to my own talking style. And I wanted to always search resources ABC first before replying to me. Like this kind of things is where you can do fine tuning. And like even OpenAI, if you go into the more advanced things, there's API access and there's fine-tuning access. We actually open up a set of APIs where you can pass in your own data and say that, hey, this is the kind of output that I expect. And then that will fine-tune the model further so that from now on, if you just query your fine-tuned version of the OpenAI model, it will reply what you want. And that's what most of our enterprise customers use. So enterprises, like especially if they want them to do certain like clinical data analysis or whatever, the default thing might not be correct. So you would put in what the data that you want and then the data that you want to see out, and that will fine tune the model further to solve your use case. So and that's actually what we do at a bigger scale here as well. So the pre-trained model is just a token completion. It actually isn't a chatbot. It can't reply to you. It just goes on and on and on. It completes your sentence for you, which is not what you want, because you're like, what's today's weather? Like question mark. What's the meaning of life? Question mark. Like that's what you will say. It doesn't say today's weather is da 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 da, because that is a response, that is not a continuation. So fine-tuning and instruction following is what we actually train it further, like with the corresponding data set and human experts, to say, if this is the prompt, the full prompt, this is your completion, and then you should score this. And then it will then learn and once again modify its weights to become a helpful agent. Steph?
Yeah, we have a couple more questions in chat related to the models, which is Lynn asked if big companies tend to work from like a single giant model, or if lots of teams create and train their own models, and then it's somehow combined to kind of create the big model.
So I'm going to assume that companies have some large model, because like, for example, Gemini is one big model, Llama is one big model, OpenAI has a few big models, but big model. So I would assume that it is a big model that is not small model. I think the scale that training is happening at, I don't think any company would, like, combining small models does not get you the same output, the quality of output, as one big model. That's the primary reason. So I don't think any company who's successful will be able to do that. They probably need to train the big one.
Yeah. And I think Sasha asked a question related to a previous point. Oh, yeah, go ahead and ask, Sasha.
Yeah, thank you. I wanted to clarify. So for the new OpenAI model, where users can store the model in their PCs, like which part is actually stored on the PCs? Like, I understand my hypothesis would be that it's pre-trained centrally, and then you receive the model on...
You receive the weights.
Receive weights, and then you fine-tune on your PC, right? And users who are using, for example, like if I wanted to build an agent who would be confidential and like store the data locally, then they would be like inputting the data, but then the results and everything would be stored locally. Is that...
Yes, everything is completely local if you use the open source model with open weights, yes.
Cool. Just one quick follow-up. So because I'm actually looking at building such an agent, where like, how do you organize the storage? Do I still rent like a piece of your storage space, for example?
You don't. The nice thing about open weight models is you don't have to use anything to do with OpenAI anymore. Just like Llama, you don't have to use anything to do with Meta. You can find there's a lot of these kind of model hosting websites that are available. So you can use hosted ones already. That's the Hugging Face, for example. You can use models, deploy models there. There's another one that I linked here. Let me find it. What is this one called? Hyperbolic. Hyperbolic is another website that you can like deploy and launch models on. So you would find a place that can host. And the nice thing about Hugging Face is it already hosts the open source model. So if you just like deploy it, just choose inside Hugging Face, like choose the open source like GPT-OSS model. That's your own. Nobody else can use it. Nobody else can see what it is. And you do whatever. It's fully cloud hosted. It wouldn't be a PC model because you likely don't have enough GPUs to make that happen. And you don't want to pay for those GPUs, because if you're going to use it for only 10 hours, you don't want to pay $200,000 for it, right? So you can think of it as it is local to you because only you have access to that model via Hugging Face. You are trusting that Hugging Face will not somehow open your model to everybody. And I think that's a good trust to have. Like, that's their company's whole business, right? So you essentially, the weights are only visible to you. The fine-tuned weights are also only visible to you.
I want to be sensitive to time. Jerene, do you have a lot more slides to go?
I can...
Yes.
We have to talk about this one a little bit. Yeah, because this one you see it quite a bit nowadays. So, like, especially if you use the models that are a little bit more slow, like the thinking models, this is a new area of very, very active research. It's where models are capable of having this thing called chain of thought. So chain of thought is where, I don't know if you'll remember in grade school, but like in Asia in grade school, whenever we do a open-ended problem, like in math, they'll be like, you have to show your work. Okay, if not, if you'll only give me one number at the end, I'm gonna dock your points, even if it's correct, because you didn't show your work. That's what actually chain of thought really is. So for example, when you ask the model a pretty difficult question, like, what's a difficult question? I'm trying to lose a few pounds, right? I'm like, I would like to have, say a healthy, balanced lunch, but then I ate chocolates for breakfast and I had so I tried to, drink some Diet Coke along with it to reduce calories. But what should I eat for lunch, for example? Then you'll see the model start thinking. The model say okay, the user is trying to hit a calorie goal of this. Their breakfast sounds like, it's very sugar heavy, which is going to be carb heavy, and then, empty calories in terms of soda. So the user needs more protein. So this is what it's thinking. It's inner monologue. This is what is called the chain of thought. The nice thing about this inner monologue is that for math, for computing, for physics questions, it can realize that it goes to a dead end. It backtracks through its chain of thought to realize, that's where I went wrong. It scratches everything and then it can continue down a different path. So this allows the model to actually you feel the first signs and the glimmers of smartness, because it can trace its own thoughts and backtrack and fix its mistakes and then find a correct solution at the end of the day. So this was something that I thought was the pre-training stuff, the fine-tuning stuff looks cute, but that was not great. This was what made modern models great, where it started being able to be capable of logical thought and deduction. And that's why you feel that models nowadays are wow, so impressive. It's because they have chain of thought now. They think about things.
Scott?
Yeah, I think that's the main one I want to talk about. Yeah, it's fine. Let's ignore this. Okay, we'll do the Q&A.
Yeah, there's a bunch. Scott and Tam have similar questions, which is, Scott asks, is the show your work process for our benefit, human benefit, since it's being conveyed in natural language versus math, right? And then Tam asks, how does it know how to do chain of thought? And is that from fine tuning, or is that different?
So with first show your work being processed in English for a benefit. It's not. It doesn't think it's talking English. It thinks it's talking tokens. The conversion from tokens is just for display, right? Because the model only thinks and only understands tokens. So its output is only tokens. And we just display the tokens. But if you're why do the tokens make English sense? Why is it that the tokens when translated to English make sense? It's because that's what it was trained on, right? So it was trained in a language, so it thinks in a language. So your inner monologue, that language that you think in, that's how the model is learn the world and is taught to reason. But I should not make it sound so human. It is just a bunch of numbers, right? So it understands the probability distribution, and so the English part of it is just the fact that these tokens are going to be near each other, and when you have this sequence of math, the sequence of numbers, the next number is going to have a high probability of that. And because it's trained in this manner, which is English, the conversion is also going to be English. Because every time I find that if I describe it like a little kid learning, people get scared, because it's not. It's just GPUs and numbers and huge vectors of math. That's it. So yeah, so that's why it's English, but it's not. It's actually tokens. And like we can don't show the English. We can just show it in tokens. But then like it's actually fun to see it think, right? So that's why we translate it.
Yeah, we've got 2 raised hands, Lynn and Tam. Go ahead.
Hey, I was just curious about the foundational model training. So is it generally, like, I think my question wasn't carried well last time. So does teams generally kind of cut a release and then they train it, the big model, just because it takes so much time to train? Or is it like teams can train different portion and then they got like in the checkpoints and get
Typically no, because the stages of the model training is sequential. So I don't think there are. Yeah, I think it's done like one stage after another. It is not like I train one side, you train one side, we put it together and somehow, because probability is not additive. Like, yeah, you actually have to go through one phase of the training. So this goes into the math. Like, if the math equation that is governing all of this is like additive or subtractive, where you can actually just like pull it apart, then it's fine. But imagine if it's like in factorials or integrals or some stuff, you can't just like plug the equation apart that. So that's how you would think about it. That's why
I think sorry, sort of operationally, like it's like there's a specific date, like you just cut the release and a binary, and then you just use that to train, and that's because it takes so long to train.
When you say cut the release, what do you mean?
It's just like code wise, right? Like there's a lot of people who contribute.
Oh no,
to the
no,
code,
no! You can't constantly update code. I think most companies, yeah. But you can think of it as discrete. But you would like to update the code and the to make things a bit faster, more efficient, more error prone. Not as error prone. Yeah.
Tam, go ahead.
I have a question going back to chain of thought. So do you need like different training technique for it?
Yes, it's actually a little different.
Like
yeah.
How, like, so before everyone is talking about tokenization and then, the transformer architecture. But for chain of thought, do you have like a different architecture? Do you have different kind of training data?
It's a different, it's the data is similar. Chain of thought training is actually a bit more interesting. It's more complicated. So chain of thought training typically involves what we call rollouts. And grading. So chain of thought, when you're training this, you want to tell the model, for example, you're training the model. Let's say, the question is like, write a joke about ducks. And these are hard things to complete, like naturally complete. So you need to train it to have a sense of humor, right? So what the model does during training time is that it will create many jokes about ducks. And the first type of training, grading, is that you got as a human, and you say, which joke about duck is the funniest? Can you stack rank these jokes about ducks? And the human will rank. And then the model will learn that this is funny, that's not as funny, So, and then you will start to understand that, hey, this is how I should start to write jokes about ducks. And then you start training a model based on the human. So that now this is called auto-grading. So instead of a human always trying to rank jokes about ducks and jokes about pelicans and jokes about toucans, now there's a model that can mimic the user's grading and penalize and reward the model accordingly. It is a lot more complicated than that. I'm simplifying it, but essentially, as part of training chain of thought, if you just Google rollouts, reinforcement learning, grading, you can read a lot more about this. But it's just a lot of experiments in parallel going, and something that is stack ranking and grading every single response and saying this is the best, this is the worst, and then the model learning every time.
Sorry, I have just one small question I asked earlier, which is in terms of, it looks like very data intensive process as well. So how do you know like which data you have to go after? If you need to train something like how do you know what synthetic data you need to create?
That's the secret sauce. Can't answer that one.
Asma has a question around just why the first response from an LLM typically tends to be more surface and not very deep. And they have a hypothesis. Is it because of cost, or is it just
no? Actually, that's just fine tuning. That's just how we fine tune the model. And this was more of a problem in the earlier versions of GPT-4. It's what I call a 3-sentence architecture. First sentence, very high level. Second sentence, a more deep, into the thing. Third sentence, a question back to you, right? So you'd be like, for example, you're like, hey, what's the what, or maybe, what should I do this weekend? The first answer would be like, oh, it looks like it's kind of sunny, so perhaps a walk in the park. And the second sentence would be like, I see that the Corn Palace Park next to you is recently open and has many da. And third question is like, do you like to take walks in the park? It would have this kind of a structure. It's fine-tuned to do this because somehow it got graded very high when it answered like that, right? It's not because of cost. It's not. But now I think it broke away. I would say probably like 6 months, a year ago is when I stopped doing this. So the new models actually don't answer it in such a robotic manner anymore.
Hani asks, what is the future of LLM models once the trainings are complete, and how far away are we from that day? And maybe that's kind of like a AGI question. And then how do we as humans stay relevant? And do you see a new way of self-awareness or training models appearing? Maybe
so as a company, I think OpenAI stance is that, and I can't speak for the company, but then if you read our CEO's tweets, you would think that, AGI is somewhere in the near future, right? So, and it's everybody defines AGI differently, right? Internally, you actually I would say you can imagine that AGI, like for example, I would define AGI as like if I ask any question, over 90% of the time it will give me the response that I'm looking for. To me, that is AGI. But to other people, they might have a different definition of AGI. So AGI is not even a scientific term by any means. So with enough data, with enough training, you can imagine that the model will be big enough that it can encapsulate most of the knowledge in this world and answer in the appropriate format. And you will understand enough about you and what you are looking for that it can answer most questions. So if you take that perspective, then yeah, we're probably pretty close to AGI. And like, how do we humans stay relevant? I would not answer it like that. AGI and AI in general is not here to replace anything, right? It is not capable of independent thought in a way. So it needs you to tell it what to do. I view AGI as a multiplier to you, to every human being, right? So for example, last time I used to write code line by line. Now I use tab most of the time because the code can be written. But I need to think about what code am I writing? Why do I want to write it that way? And I actually debate that with another agent on the side, like, this is not correct. And it's like, no, you're smoking something. I'm like, no, you're wrong. And like, we have healthy discussions, but I still own the code and I own how I want to structure it and why I wrote it that way. Same thing, like there's other things of my life that I've like just completely outsourced to AI. For example, what to cook. I just take a photo of my pantry, take a photo of my fridge, tell me, AI, what should I eat for dinner? And then all of my picky kids' habits are all inside. So it knows, because it has memory now, like OpenAI, our models have memory. So it knows what I like, what my kids like, and it can do all that. But I still have to do the cooking. So like I view it as it augments my life in ways that I previously would have to spend time and effort on. But you as a human are the driver still?
We are at 3:00. There are still so many more questions, but we got through as many as we could. Jerene, thank you. Just thank you for your generosity all the time. Really appreciate you. Okay, thanks everyone for joining. Hope this was helpful.
Bye.
Bye.